So anyway, I want to talk a little bit about what we're doing at HPE in the realm of Lustre and other things as well. And I kind of have three main topics that I want to talk about, but I definitely want to talk about the development efforts first, right? So our main focus is, and have been for quite some time, performance and stability. And stability is specifically about how do you get those super large systems to actually stay up for a decent amount of time. As James pointed out earlier, big systems fail, and they fail frequently because it has too many moving parts. And it doesn't matter that the hardware components being used is the best one we can manufacture today, it will still fail on its own when it decides to do so. And there's nothing we can do about that. We also try to make sure that we can do what we call network transparency, supporting not just our own networks, but any other network type out there that is popular, and deliver the same performance on all of these different things, which means a lot of tunings, a lot of activity, making sure that the drivers actually work in an equal way, and so on and so forth, which is something that takes a fair bit of our time. We also work in a lot with OpenCFS, mainly because some of our largest customers are OpenCFS users, and we think we can actually add to the quality of OpenCFS for many of these users. And I will talk a little bit about OpenCFS in a different slide too. Now, the product focus is really Lustre 99% of the time. We do have DMF, has been mentioned here, because we think that is an integrated part of a data center ecosystem when it comes to how do you manage your data, not just the fast access data, but also the archiving model and distribution and so on and so forth. And those of you who were at the LAD last year in Bordeaux may remember me talking about what we call the data mobility framework, which happens to have the same acronyms, but it is kind of a next step that we're still working on. We're also putting a lot of effort into DAOS, which is no big surprise, because we do think that this could be an interesting top level on a Lustre 5 system. We don't see it as a replacement, mind you. We see it as a top-level IO tier that can be added to Lustre, hopefully fully transparent, but at least give us more capabilities than some of the Lustre limitations we see today. And of course, there's a few skunkworks projects on the work everywhere. Now, our team have unfortunately shrunk a little bit over the last year, and I want to thank James for mentioning Olaf, who is a great loss, because that was very unexpected, and we've been scrambling to kind of make sure that his work has been taken care of, and a lot of that is now in good hands, so we know that despite the fact that it is a big loss, we are trudging ahead a lot. Now, the other thing that we do a lot of is testing. So every single software release, every single hardware component is tested to pieces, literally. And we run, depending on what type of product it is, what type of network it is, and so on, up towards about 3,000 different test cases in an automated sweep that takes several weeks to complete. And those are a lot of stress tests, those are a lot of cable pull tests and other things in order to make sure that we have a very resilient system. And we do detect and find a lot of bugs which get fixed, and then we retest and so on and so forth. Despite that we do all of these testing, guys like Mr. Simmons still breaks it in scale, which I think is annoying, and you should be a little bit more careful with the tools you have. But anyway, which way, it is a big part of what we do. So we have a big team that works together for getting all of these things done. Now, I want to focus a little bit about the OpenCFS work we're doing. And I had a slide last year that was similar to these, but we've improved performance. Now, we are looking at all of different types of, let's see if I can find the light, that's right, different types of IOs, and it was mentioned yesterday that nobody really does direct IO, and a lot of our customers do use direct IO, so we test both with direct IO, we test both with fixed time and fixed data, and we do the same with buffer as well in order to get kind of a full gamut of these things. If you look at this slide, you can see and I think, unfortunately, they gave me the PDF and not the PowerPoint, which is going to be a problem. No, it is PowerPoint. Sorry. It's just that one was supposed to come up a little bit later. That's okay. So anyway, but if you focus on, so this is Flash, obviously. Flash and the OpenCFS is not a good idea. You can see the performances, when you use with compression or without compression, that we are close on some of the numbers, but not others. And buffered is a little bit better. It's the same ballpark, and we actually focus on those two, buffered, fixed right. We are getting close, but if we try to use compression, it doesn't work well with Flash. Contrary to what Otto was just saying, we should use Flash because that's where it works best, but not on disk. Now, if we switch that to a disk solutions, and this is a standard disk building block we have, you can see that the actual performance numbers for both buffered and grid rate numbers, in this case the parallel clustered rate, they are in fact actually fairly decent. And if we add compression, specifically on buffered, these numbers go way high. Now, this is obviously benchmark data. We have used in random data in order to get something that is not too easily compressible, but still. So we see a lot of value in OpenCFS, mainly for disk systems. And if we can then augment this eventually with client-side encryption for the Flash system, we have a pretty good, decent ways of reducing data on these systems. Now, the problem with OpenCFS is that you can't really run that on all of your systems if you want to have the maximum performance of everything. Now, that is required if you want to do checksums, but we can give away, checkpoints. Sorry, snapshots. I keep getting things mixed up today. But we are willing to give that up to have the best of both worlds. So we are currently working on a number of projects where the recommendation is using LDiskFS for metadata, LDiskFS for Flash, but OpenCFS for disk in one file system. And that is something that gives us the best of both worlds, best performance and best reliability in these systems, and actually works pretty decent. So that is our standard default settings on systems we ship today. And we continue to add more efforts into this because obviously there is a lot of value in having a second source. Plus the fact when we use OpenCFS, we get a little bit more usage out of disk drives instead of traditional parallel clustered RAID. So I won't talk too much about that, but I do want to talk about another thing that's really close to my heart, and that is advanced monitoring. And this is not just monitoring your performance or things like that. That is monitoring everything. Because if you look in a data center today, you have these big complex supercomputers with a lot of GPUs, you have complex networks, and you have storage. Everything is monitored differently, everything is monitored depending on what engineering or myself think is the right values to see. Now, we frequently understand that that is not what customers necessarily want to see. So what we've added to the system is a full Redfish Swordfish API implementation. And this means that we can monitor anything in the system and provide that to the outside world for inclusion in other tools and so on and so forth. I won't spend too much time on these slides. You can read them there. But these are standard services we run on our systems. They are clean, they're easy to use, they're easy to implement, it's easy to figure out where things are. And if you actually look underneath the covers, we have a push on this one. So all the delta is sent. So we can actually export a large amount of data without saturating management networks nor the database service on the client side of things. Inside the system, everything is organized in a hierarchical manner, so you can essentially go into one of these groups, and underneath the chassis, you will find subgroups with everything in the chassis, and that means everything. So there's not if there is a measurement point in a component, power usage in a disk drive, vibrations in the disk drive, temperature of a disk drive, we can monitor it, we can put it into systems, and we can get statistics out of these things. What we do with this is usually make sure that we monitor all the drives and just look at drives that actually doesn't fit the mold of the rest ones. drives are a little bit hotter, that vibrates a little bit more, that consumes a little more power. And those drives are then being monitored a little bit more closely. We've had this for a long time with slow disk detection and so on and so forth, but now we're using these tools because they have a higher granularity when it comes to getting these data out. Now, what's interesting with this is not just this implementation, and it continues getting better because we can monitor all the Lustre features, we can monitor all the OS features, we can monitor the hardware, we can even monitor the network components. But we don't need to do that last one, because if you look at what we're trying to do as a company, we have the exact same tools for slingshot monitoring. We have similar tools that we can use for InfiniBand monitoring as well. And we have same tools, set of tools for monitoring the compute. That means essentially we have the foundation for a single monitoring tool that will go end to end from compute all the way through network to storage and back again. And that is what one of the things we're working hard on, trying to get a comprehensive view instead of disconnected components in the system. So essentially it allows us to monitor a job in every step of the chain about what it does, how it does it, and if there's any problems by using different tools. Now, the biggest problem here is the fact, as most of you already figured out, when you have all of this data, how do we actually find that needle in the haystack? So this is also something we're looking at, and this may be an area where we might, and I use a lot of affirmations here, start using some AI tools to start figuring out patterns, learn over time, and actually use that as a way to identify specific trouble spots in the system going over. Now, in addition to all of these things, obviously we can look at the different resource trees, we can look at events. Those events could be set to automatically push to another server. It could push to a high-level collection tree and so on and so forth, and that's both for events and generic metrics. Now, we use this internally in the current solutions for our monitoring there. So the performance monitoring you see in our systems today is all based on data we pick out of this. So we use this internally as well. But the important thing here, and I think this is the biggest message I have, we are trying to take it just beyond storage. It is not just the actual storage system that's interesting. It is the end-to-end from a data center point of view. Now, actually, good time. I can actually take it a little bit slower and tell a joke or two. I won't do that. I'm not that funny. Now, the last thing I want to talk about, and this is something that's have been partially discussed at other events, but it's been focused mainly on what we do for automatic tiering and using policies. Now, there is a component in this tiering that is around the indexing components. Now, indexing is a totally different way of doing a file system analysis and a file system replication. I mean, I'm not trying to bash Robinhood, but honestly, Robinhood can't really keep up when you have a system that does, a few million file creates per second consistently and have a lot of changes and so on and so forth. It's really hard to keep up with it. And you're limited by the search capabilities of a database that on a single server, which also has some limitations. So what we're doing is we use index files that are located on the file system. I can't claim we came up with this idea. We stole it from Los Alamos with their Goofy project, and we optimized it for our current Lustre solutions. But the idea is that you create index file on the root level of the system, but you can also create indexes at directory levels where you have a lot of activity or you have a lot of files in it in order to be able to index in parallel on the file system. So this isn't real time, but it is fairly close to it. You can set it to index every 5 minutes if you want to. That's really not useful, but we normally index every hour or every 2 hours or something, and that's good enough. And those indexes rarely take more than a few seconds to do. because they're parallel, they can do this very cleanly. Now, it does do this, as I said, on the Lustre file system. It creates flat files that are hidden on the file system and invisible files, but they're fully accessible even to end users if the admins allow that, or it's only an admin tool, depending on how you see things. What's interesting about these things is that it can keep up with any scale. We've tested this on really large systems, and it pretty much keeps up with most systems unless you have extreme peak activities, because obviously that takes longer to index once you're done. But it's not in real time, and we do not use the changelog for this. So we are not changelog dependent. We can actually use the changelog to provide hints where a file, where a lot of files have been changed or added or deleted to the file system, so we can do a incremental indexing of that directory or that part of that directory tree to make it easier. But honestly, for the most part, I do not like having the changelog turned on because it actually slows down the file system quite significantly. Now, what can we do with this tool once we have it? Well, we can do anything. First of all, we do our policies, so our flash managing, data tiering, and all these things. That's something we can do really quickly. One of the problems we heard yesterday from Marco about using DMF to get a list of files that needs to be deleted. If you turn this on your system, you can delete those files in seconds instead of waiting minutes or even longer to get that file out of the DMF system. This is instantaneous, it's fast, it really does the work. So I can really recommend that. We can also get usage report, we can get rebalancing, a lot of things you can see for yourself. But what's more important here is a lot of these things are policies run by the policy engineer, and it does that essentially on even or specified intervals. Whereas if you actually use a query tool, which is more like searching a database, so you need to know a little bit about SQL language to do so really efficiently. And if you really want to do things smartly, you can do a lot more. But the policies and the queries really add up to a powerful tool that can allow you to do a lot more. Even archiving things or listing things, finding things is super fast. And this is really the key point, that this is super fast. It also has no impact on your Lustre metadata services and negligible impact on the file system as a whole. And it can scale to almost any size. So some of these things we can do. I just want to give you a few examples. Finding the 10 largest files, that in this case is larger than 50 megabytes, 500 megabytes in size. I did a few different ones with different, on the file system as a whole, on my own directory, and some other things in this. And this took, not even seconds. It took milliseconds to accomplish each of these on a decent-sized file system. We have another good example, finding old files where we need to get a certain date. Now, there was a comment yesterday about, I think it was in the Robinhood section, about having intervals in seconds and trying to figure out how many seconds is that if I need to do 2 weeks or something like that. Well, as luck would have it, in SQL you can actually write a little math script that actually figures it out for you, because I can't keep track of all those seconds with, it's a 3, 4, 5, 6, 7, 10 zeros after it. But this makes sense to me. I can figure that one out. That was the size, by the way, here, but I think we have the same time here, so we can do that in seconds as well. And again, it does this really, really quickly. Now, my favorite one is this one, which is creating a histogram of all the files in the file system. I do this all the time. I have to do this often. I used to use a nice tool that came out of Oak Ridge that took hours, if not days, to compile and go through the entire file system. We did this on a file system. As you can see, there's a little bit of scripting, and we're trying to fix that, by the way, because some of this, the actual query stops. Actually, the entire command looks like this, which is something you don't just type. You copy and paste. And the actual query stops here. And then it puts it into awk that does all the formatting. Now, I don't know about you guys, but I was trained on ORC 20 years ago. I hardly remember anything. And so luckily I got people who knows it better than I do, so I got help to do some of these things. But I can kind of debug it because I have done it in the past, but I couldn't write it from scratch because I'm not that good anymore. But anyway, it's kind of an interesting thing. So you can see the subdivisions. So any files less than a kilobyte, I have 140 of this, that's 28, and so on and so forth. This is actually on a file system with 1.8 million files. And just to give an idea about this took 309 milliseconds. 1.8 million files, 309 milliseconds. I just want to let that sink in because that is a lot faster than anything else out there. If you had this in a database system, it would still take a lot of seconds to do. Now, how does it scale? Well, it would take a little bit longer, but we actually did a test with more than 500 million files, and that took 68 seconds for 500 million files. So I just want to point out that some of these things are extremely powerful. Some of these things will deliver performance and gain to you. And we started using these, and some of our customers are starting using these on a day-to-day basis because it is easy to get data out of the system in real time, or more or less real time. And you can do this very easily. You can pipe this to reports that it runs automatically, and then you can harvest them once a month or whatever. There's a lot of power in here, and it ships with every one of our systems. Most of the code is available in open source, so it could be implemented even on non-HPE implementations of file systems if you're interested. And it's kind of an evolving tool, and we keep making this easier, making some of these scripts single line commands instead of 4 lines of weird text. And we're trying to make sure that we can make this more usable over time. I'm working on a cookbook at the moment that will have a lot of these recipes that can just be copied and used either in policies or in queries for the systems, and over time this will evolve. So, wrapping this up a little bit, the summary is at the moment that Lustre is live and well at HPE. We're still putting a lot of effort into it. We're still putting a lot of other components on top of our Lustre efforts. We still have other file systems at HPE. Some of them are known, some of them are competitors, I would say, to Lustre in some cases, like Vast and Vecca. But that's because we are a big company with different divisions that doesn't necessarily play well together with others. But that is kind of the point here. I talked about the testing. We think that is key because that's how we find problems and have a lot of fixes that goes in the system. Obviously goes back to the open source community, but some of them doesn't land until 2.16, some of them doesn't land until 2.17 because of timing and so on and so forth. And then finally, I just want to say that for us, it's not just about the file system. It is about the whole ecosystem, including all of the compute parts, all of the network parts, because if one of them doesn't work well, the entire system will suffer. And we kind of need to look at this in a holistic view. And contrary to what we hear from the competition, Lustre is going to be around for a long time. We may augment it with the DEOS, as I mentioned earlier. We may augment it with other tools in the back end, like a fully integrated DMF using the changelogs instead of, it's not using the indexing instead of changelog, for instance, to speed things up just as a concept. But there are all other things going on as well. So with that, I will say thank you and answer any questions that you may have. And by the way, I usually don't do this with glasses on, but honestly, my eyesight is failing because I'm getting old.
Thank you, Torben. Question?
I'm not sure if I quite understood it. Is this tool, is it looking into a database or is it querying the file system directly?
Neither. So the indexing creates database-like files, but flat files that are indexed on the Lustre file system. So you're reading them in parallel when you do a query, because they're distributed on the file system. There's no database itself. There's no database engine like MySQL or Cassandra and anything else. This is just flat files that are read by the query tool.
Can you still query even if the file system is down?
No. So it's on a live file system. If the file system is down, you can't access the index files. Hence, you can't do anything.
Perhaps more comment. In BGFS, they have this beehive, which also uses this goofy indexer.
Yep.
But they do it both. They can do it both in the cluster file system or outside of the cluster and just mirror the thing.
Yep.
So you could basically query even if the cluster is down.
We could. And I mean, we have just not taken that step of exporting those index files to a separate system because, again, that requires another node that you need to access and so on and so forth. We're trying to use this because any Lustre client on the system, whether it's an admin node or actually a compute client, can use these queries. So you can run this query as, let's say, if you have if you have, for instance, using Slurm or PPS Pro, you can have a Prolog script that actually does a query first to find files, to create the index and the location of those files, to speed up a job, and so on and so forth. That's why we want to use it as a tool inside the file system rather than just getting reports outside. And if my file system is down for any reasons, I'm more keen on getting the file system back up again than doing some indexing or what have you. So it is what it is.
A question regarding ZFS compression. So have you tested scalability? How many clients used during such testing? What impact of the many clients to the server there?
Well, so far we've only run it really in the benchmark system. So we've run it up to 400 nodes in a Cray EX system, and it seems to be scaling nicely. I think the big problem here is the amount of data that you actually try to write to the file system. And again, same thing, it's issue as you have. How compressible is that data? We don't actually check if it is compressible or not. We try to compress it at any given time. So some of these files go through a process where you're trying to compress it, nothing really happens, and the files is the same size. So we're not talking about 2, 3, 4x on the entire file system. We're talking about an average about 1.5 compression compared to capacity in average on a user system. Benchmark systems obviously aren't real systems, so yeah.
Thank you.
You mentioned that Robinhood was not suitable for a very large system, but what constitutes a very large system? Well,
that's also a good question. How long is a piece of string, right? But I mean, if you have a system like some of them you heard about, let's take a good example. The system which Marco talked about yesterday, which is a 100 petabyte system. It has 6 metadata servers and 6 MDTs, so 6 change logs essentially that needs to be ingested. You have a file system that can do close to a terabyte per second and so on and so forth, with a lot of activity going on in it. In those cases, it would be very hard to keep up with that system. But if you have a system with little activity, where most of that activity is read-only, for instance, not a big problem. You can actually do that with Robinhood as well. But we've seen that the system gets larger and larger or more active. It gets harder and harder to keep up with the change logs. And that's really the biggest challenge here.
For the monitoring solution, you said that you're not using change logs or using any metadata operations. So how do you keep track of the regular changement?
So we can use changelog to indicate a lot of changes in a directory or a directory, but I prefer not to do so. So essentially what the system does that it looks at each sub-part of the file system that is responsible. So we have an indexing agent at different levels, and it essentially looks downwards and finds changes, put it into the index files, and that's it. So essentially it rescans the file system, but it does so on a much lower granularity than top down and try to do a full directory scan.
So there is still regular scan of the
yes.
Of the
There's still a scan, and if you actually look at it, you have a small blip on metadata, but it doesn't affect metadata in general. And these updates to the syncs are usually in the 1 to 2 second range. It's really fast.
So it's more a distributed scan of the
yes,
system.
It's a distributed scan.
Regular
yes.
Scan. Okay, thank you.
So I want to ask one question related to that. Is that only admins that can update these files, or users can do also the updates? So
you can't update the files, because that's done by the Brindexer tools or the indexing tools. You can access the file because it's part of the Lustre file system, so it's on the root directory of the Lustre file system. Now, whether you as a sysadmin wants to let users do those queries themselves, or if you want to keep it as a sysadmin tool, that's up to the site. Okay. There's nothing stopping a user from running a query if they understand what they're doing. And we have several sites where they're doing exactly that because, as I mentioned, they use it as a precursor to submitting a job and finding files and so on and so forth.
Other question? If not, I have one. I have one also. You talk about the redfish.
Yes.
And I wonder if your idea behind that is to expose some stats from Lustre inside the redfish systems.
Yeah. Oh, yeah. That is what we're doing with the redfish. Swordfish is more for the hardware components, obviously, but redfish is looking inside of Lustre, and we made sure that we have hooks to every piece of Lustre stats there is in the system, and then some. So yes.
Okay. Great. Thank you.